Okay, so let's look at the next aspect, I suppose, in your Venn diagrams, and that's using them to solve problems. Okay, so a lot of the times we're not just listing them out for the sake of it, I suppose. We're listing them out so that we can use them to solve different questions we have, or to kind of organize things in a particular way, to work out where people might be in terms of whether there was many people who liked both things or things like that. So we need to be able to kind of use our Venn diagrams in order to do this, particularly because a lot of times that's how the questions are presented to us. Um, so as I said here, you have to be familiar with the different relationships that we're using. So you have to be able to recognize those and recognize the interactions between those as well. So if somebody's in the very intersection, they are still in each of the three outer intersections for a three set one. So A intersection B, including the fact that that includes the middle part as well, different things like that. So the steps in solving these questions, first of all, we list all the information we have. Then we are going to let x be the unknown value. We won't always have a clear, just explicit kind of unknown value, but when we do, we're just going to call it x. It's just the easiest one to choose. We're next going to find the number of elements in each region in terms of x. So we look at our diagram, and in any other region where it kind of touches this unknown region or has this unknown value, we're going to rewrite that using x. We're then going to find the number of elements altogether, and we're going to add up the elements and equate it to that and use that to solve for x. So in most of these questions, you're going to be told exactly how many people are in the set. So we'll look at the first example here. We'll just jump straight into it. It says there are 80 students in first year. So I know straight away there are 80 students in this universal set. There are two clubs running, Club A and Club B. So I can label my diagram. Club A has 30 students. So we're making sure that Club A has 30 students all together. That's the whole circle. And Club B has 40 students. Again, the whole circle is 40 students. 30 students are not in any club, so they're on the outside. So the 30 students here who aren't in any club are not in either of the circles. So we know that 30 is neither. We've drawn that in here. I just kept it kind of clear for ourselves. I mean, 30 is kind of given to us. We need to work out how many people are going to be in both clubs. So let's say that we call that X people. And we can work this out fairly quickly, but let's just say we call that X people. If there are supposed to be 30 students in the yellow circle overall, and we know that there are a certain number in the middle, we don't know how many, but we're going to say X, but it's a certain number. We know that in this yellow part, it's not 30 people. Okay, it's not 30 people, it's 30 people, take away whatever the middle bit is. So it depends on what the middle part is. Similarly, in the pink part over here, there were 40 students altogether in Club B, but in B only, we take away the ones who are in both clubs. So in the B only section, we take that away. Because then if we were to add those together again, say we were to look at all of B, it would be X plus 40 minus X, which just gives me the 40 that I need. So Club A only is 30 minus X, Club B only is 40 minus X. And what we can do now is take each of those sections and add them together. And I know that when I sum all of these, my answer should be 80, because I'm told that the universal set there are 80 students in first year altogether. So adding all that together, the fact here that I have a plus x and a minus x, they're just going to be eliminated. So I'm going to look at my numbers first of all. So I have 100 minus x equals 80. I have 100 minus x equals 80, and that means that x must be 20. That means that x must be 20 then. Okay, so you may be able to work some of these out for yourself without even having to do a lot of that extra work. Okay, you may be able to work that out for yourself without having to do all of that additional work. So it's just a matter of kind of figuring out what works for you. So let's look at another example. So a group of 38 students were asked if they had ever been to France or Spain. The number who had been to Spain was only 3 more than the number who had been to both. So 3 more than the number who had been to both. Twice as many had been to France as Spain. 4 students had not been to either country. So let's lay all of this information out. 4 hadn't been to either, so let's put that on the outside altogether. Let's start with how many have been to both. We don't know, so let's call it X. Okay, we don't know, let's call it X. I'm going to go with Spain then. Okay, so Spain only, we know it's 3 more than the number who'd been to both. So it'll be x plus 3. That's coming from the thing I've highlighted in yellow there. So 3 more than the number who'd been to both. So x plus 3. Twice as many had been to France as had been to Spain. Okay, so let's look at how many had been to France altogether. Okay, so France twice as many as had been to Spain. Okay, so if we look at how many were in Spain altogether, it'll be the x in the middle plus Spain only. So France is twice as many as that. That was 2x plus 3, which means France is 4x plus 6. Okay, now we don't want France altogether, we would just want to get France only. So we take the 4x plus 6, remembering that's a total, that's how many were in France altogether. I'm going to take away x because that's the middle part here. I'm taking away the x from the middle, and I get 3x plus 6. And that's how many people were in France only. Now I've laid out all of my information. If I add all of those up, so 3x plus 6 plus x plus 3 plus 4, it should be equal to 38. There are 38 students altogether. So adding all of those up, I get 5x plus 13 equals 38, which means 5x is equal to 25 and x is equal to 5. So 5 students have been to both countries. So you can kind of see there the kind of steps that we're taking. You have to just start with that idea of labeling the diagram in terms of how many had been to both, the region that we don't know. So that's going to change. It's not always going to be the middle section. So we kind of have to adjust according to the question that we have. So looking then at this 3-set Venn diagram next as another example for us. In this 3-set Venn diagram, we're told 80 people responded to a survey. So there's 80 people altogether. So I know straight away that my universal set is 80 people. My universal set is 80 people. 36 said they like rock music, 40 said they like country, 54 like pop. 8 said they like all 3 types. So the 8 who said they like all 3 types, they're going to be in the very middle, so let's just go ahead and put them in. 14 people like rock and country. So rock and country is 14 people. 24 people like country and pop. Country and pop, 24 people. Let's tick these off as we go. X people like rock and pop, but not country. So rock and pop, but not country, without country, is X people. And let's look at where that's going to be. That's going to be this section here, is X people. So that's my unknown section now. That's my unknown section. Okay, let's use what we know here. So rock and country is 14 people, but there's already 8 people in the middle, so there must only be 6 people in this section. So the rock and country only, without the pop, is 6 people. Okay, remember, rock and country is the entire section here. But that's not what we're looking for. We are looking for what was left over. Similarly, country and pop is 24, but I already have 8. So that means I have 16 there. Okay, now we need to look at some of these only sections. So in country, there are 40 people. So country has 40 people. So I can use that to work out what the middle section is. So if I add up what I have already, I have 30, which means there must be 10 left to go in the middle section there. We're going to do similar to pop and rock. So pop was 54, rock was 36. So this is 54 and this is supposed to be 36, this entire circle. So if we focus on rock, first of all, it's supposed to be 36. At the minute, if I add it up, I have 14 plus x. I have 14 plus x here. Okay, I have 14 plus x here. So we need to do 36. We're going to take away that 14 and we're going to take away the x to see what's left. So 36 take away 14, so 22 take away x is what's left in rock only. In pop only, Again, same idea, 54, but I'm going to take away the 16, take away the 8, and take away the x, and see what that leaves me with. And I get 30 minus x. So my 30 minus x going here as well. Okay? 30 people liking music, or 30 minus x, sorry, liking pop music only. 30 minus x liking pop music only. Okay, so let's go ahead then and work out the overall answer for our question here. So what we want to do then is we want to take all of this information and put it equal to 80. Okay, so we're going to take each of these parts, so 22 minus x plus 6 plus 10 plus x plus 8 plus 16 plus 30 minus x, and I'm going to say that that is equal to my overall answer, my 80. So let's summarize all of this. Let's bring my numbers together. So 22 plus 6 plus 10 plus 8 plus 16 plus 30 gives me 92 minus x overall equals 80. Okay, so 92 minus 80 equals x, so x equals 12. X equals 12 altogether. So there are 12 people who like both. Okay, who like both. We were asked to find pop music only. So 12 people like rock and pop. How many like pop only? So pop only was 30 minus x, so 30 minus 12, which is 18. 18 people like pop music only. Okay. So we can see a little bit trickier than some of the ones we've been working at earlier, but the main thing still holds. The first step we want to do, or the first thing we want to do, is we want to lay out our diagram. We want to lay out what information I have. Okay, we want to lay that out first, and that's what I'm going to use then in solving my questions. So I need to start with kind of what information do I have available to me, and then go from there. Let's jump straight in. So 80 students were asked what they had done during the summer holidays. Some got a job, some went on holidays, some did both, some did neither. Okay, so 1/5 of the students in the group did neither. So there were 80 students altogether. A fifth of those is the same as me dividing it by 5. So 80 divided by 5 or multiplied by 1/5 gives me 16 people. So 16 people did neither. So they'll be on the outside. Okay, so I've ticked off this part, I've used it. 25% of the students got a job. 25% is the same as a quarter, so dividing it in 4, 20 people got a job. Altogether, 20 got a job. Of those students who got a job, half also went on holidays. So if 20 got a job, 10 of them went on holidays, and 10 of them just stayed in their job. Okay, how many students are left? Well, let's add up what we've used already. So we've used 10, or we have 80 altogether. We've used 10, we've used another 10, and we've used 16. So that's going to be, take a 20, 60, and that's going to be, so 70, 60, and take away 16. Why for now? Do this one out. Minus 10, minus 10, minus 16 gives me 44. Gives me 44. Yeah, there we go. That would make sense. So it gives me 44 here to fit into that little section there as the number of people who went on holidays. So you can see in that one, we were able to kind of do that one nearly without giving it an X value. And that's kind of sometimes something you can do with maybe the smaller ones, the 2 set ones, a little bit harder with the 3 sets. So with our 3 sets, let's just work through it. We might start from the bottom here because I can see straight away on the bottom it says 8 students have all 3 apps. So that goes straight into the middle. And we'll tick it off. X students have WhatsApp and Snapchat but not Instagram. So WhatsApp and Snapchat but not Instagram is going to be this section here. So WhatsApp and Snapchat but not Instagram, this section here, my X part. Okay. 24 students have Instagram and Snapchat. So 24 students should be in Instagram and Snapchat, which is this region here. But of that, I've used 8 already. So that's going to mean that there are only 16 left to go into that section there. Okay, so I've used 8 of those already. So there's only 16 left to go into that section then. Okay. So looking then at the next little part. So again, working our way back upwards. 14 students have WhatsApp and Instagram. So again, 14 students, we already have 8 included. So we're going to have 6 then in the top part here. Okay. 54 students have Snapchat. 54 students have Snapchat. So in this part, I'm going to do 54. I'm going to take away the 16. I'm going to take away the 8. And I'm going to take away x. Remember, x is still just a number. We don't know the value of it, but it's still a number. So that gives me 30 minus x to go in the Snapchat only section. 40 students have Instagram. So 40 students have Instagram. I've already used these ones. That gives me 10. So 10 students here have Instagram. And then looking at how many students have WhatsApp, 36 students. So 36, take away the 6, take away 8, and take away x there as well. And let's just do that sum. 22 minus x. Okay. So each of the students in the school has one. It says each of the students in a particular school has one of the apps. So we know there's no people on the outside. So if I now take the part B here, where it says there are 80 students, find the value of x, we take each of these sections, and I generally work from left to right, and then move down and do the next line from left to right, and then do the last section, and it should be equal to 80. Okay, focusing on my numbers first of all. So it was 22 there that I've hidden. 22 plus 6 plus 10 plus 8 plus 16 plus 30 is 92. Minus x equals 80. So actually similar to the last question, we're going to get this time a similar value for x here. We get that x is equal to 12. Okay, if we want to do it out fully, we get minus x is equal to 80 minus 90. Minus x equals minus 92, sorry, minus 12, and x is equal to 12 then, in that case. Okay, so x is equal to 12. We're just asked to find the value of x. We weren't asked to go back and find the value of each individual section, and you also don't have to go back and find the value of each individual section there. You don't need to edit your diagram at all, and in fact I would leave the diagram in that case so that it's easier for an examiner, for me correcting the test or whatever it is, to see the method you've used and to see the steps that you've taken. Looking at part C, it gives me 4 different statements. Each statement's written in mathematical notation and in English, and we need to complete the table. Okay, we need to complete the table. So the first statement says 8 is equal to the cardinal number of W intersection I intersection S. And what that means is 8 students have all 3 apps. So 8 students have all 3 apps. 24 students have Instagram and Snapchat. So 24 is equal to the cardinal number of Instagram and Snapchat. So 10 students have Instagram only. So because this is Instagram, take away WhatsApp and Snapchat, so Instagram only. And more students have Snapchat than have WhatsApp. So the number of students who have Snapchat is bigger than the number of students who have WhatsApp. So you can see there how important it is to really know that notation inside out as well. So it's not enough to just know the different sets and to know how to answer those. You also have to really know the notation because they don't come up separately. Okay, we have to know every kind of little part of it, and we have to kind of know here. So let's keep going. Let's look at another question. So this is 2007. So a survey of 40 students was carried out to see how many owned an MP3 player, a digital camera, or a CD player. One student does not own any of these. X students own all 3, while 2X own an MP3 player and a digital camera, but not a CD player. So we have to construct a Venn diagram and solve for X. So let's draw our Venn diagram and see, can we plot everything into it anyway nice at all. Put that on. Make it a bit bigger. Okay, so let's have a look. So is there anything we know in the middle? X students own all 3. Okay, 2X own an MP3 player digital camera, and CD player. So 2x own an MP3 player and a digital camera, but not a CD player. So 2x is going to be here. Okay, 2x just above. So let's see what else we're told. One student does not own any. Okay, there are 40 students altogether. 10 own an MP3 player and a CD player. So 10 own an MP3 player and a CD player, so that's this section here. We've already included X people there, so this will be 10 minus X. Sorry, I keep forgetting to put the pen back on. So 10 minus X. 11 own a digital camera and a CD player, so this would be 11, take away the X part in the middle there. 22 own an MP3 player. So if we look at the MP3 player here, it should be 22, but I take away the 2x, I take away the x, and I take away the 10 minus x. The last one's the one to be really careful of. So 22 minus 2x minus x minus 10, and that's going to become plus x now because it's minus x. So looking at that one, we get 12 minus 2x. For MP3 player only. 22 own a digital camera, so taking my 22 and I take away 2x, I take away x, and using our same rule here again, taking away 11 minus x, so it's 22 minus 2x minus x minus 11 plus x, so we get 11 minus 2x. Okay, 11 minus 2x. We have a lot of x's going on here, but it's fine, we're going to manage it. 24 own a CD player, so same idea again, minus x minus, we have to be careful here now twice, because we've that same issue we've seen coming up there, it's coming up twice in this one now, minus 10 plus x, minus 11 plus x. So we get 3 plus x. Okay, we have to solve for x. We have to solve for x. So let's take that down into the squares here. We'll do that little question afterwards. So we're going to have to add all of this information. And that can seem quite daunting, okay? And the key thing is just to take it slowly. 12 minus 2x plus 2x plus 11 minus 2x plus 10 minus x plus x plus 11 minus x plus 3 plus x, and it should be equal to 40. So let's focus on the numbers first of all. So 12 plus 11 plus 10 plus 11 plus 3 is 47. Minus 2x plus 2x, so they're gone there. Minus x plus x, so they're gone there. Minus x plus x, so they're gone there. So we get 47 minus 2x. Okay, 47 minus 2x. I feel like I'm missing something along the way. I'm missing my plus 1 on the outside, so careful not to forget that over here. So that'll make it 48 minus 2x equals 40. So minus 2x equals 40 minus 48. So taking 48 away from both sides. Minus 8, dividing now by minus 2, gives me x is equal to 4. So there are 4 people who own both. The 4 people who own both. The second part that says, hence calculate the percentage of students who own one item only. So MP3 player only was 12 minus 2x. So 2x is 8, so that's going to be 4. Digital camera only was 11 minus 2x, so that's 3. And camera only was 3 plus x, that's 7. Adding all of those together, I get 14 out of my total 40. And to change it to a percentage, I multiply by 100. Okay, so to change it to a percentage, I'm going to multiply by 100, and I get 35% for part 2 there. So again, always a little extra bit. There's always a little extra thing to look at with these ones. So it's just something to kind of watch out for yourself. There's always something, not trying to catch you out per se, but there's just always something extra going on. So we're looking now at a researcher. So we've just a few, I think we have another question or two to look at here. Yeah, just 2 more. So we'll look at the last two quickly. So we're looking at different types of diseases here. So there's 100 people altogether, 100 children altogether. 31 had none of the diseases, so that's going to be on the outside. 2 had all three, so that's going to be here. 2 had measles and chickenpox, but not whooping cough. 6 had whooping cough and chickenpox. 6 had whooping cough and chickenpox. We've already included 2, so that's going to put 4 there. 11 had at least 2. 11 had at least 2. At least 2 is including all of this section here. Okay, this kind of shape in the middle. So everybody here has at least 2. The people in the middle have 3, but they all have at least 2. We've already included 8 people, so if that has to add up to 11, there's 3 people unaccounted for. 18 people had measles. 18 people had measles. So if I know the measles circle should be 18, I take away the ones that I have now. So 18 take away 7 is 11. 40 had chickenpox, so take away again what we have there, and that's going to be take away 8, so 32. Okay, and to work out the last little section, so we're not told how many people at that, but we know there's 100 people altogether. So from 100 we can take away all the information that we have: 11, 2, 32, 3, 2, 4, and the 31, and we get an answer of 15 for whooping cough only. Find the probability. So we see now they're trying something different. Probability that a child chosen at random had chickenpox. So how many people had chickenpox altogether? So we can nearly do that looking at the question. 40 people had chickenpox altogether. There were a total of 100 people. So the probability that somebody had chickenpox is 2 over 5. So there's a 2 in 5 chance that if I picked somebody at random, they would have chickenpox. Now a similar question to one we did earlier, so relating the notation now to the meaning. 6 had whooping cough and chickenpox, and that's how we write it in set notation. This one on the right hand side means 36 people. 36 had chickenpox. 36 had chickenpox, but not measles. Okay, 36 had chickenpox but not measles. We're not mentioning the whooping cough at all because it hasn't mentioned anything about that one. So 2 people had measles and chickenpox is the intersection, but not whooping cough. We're taking away whooping cough at the end there and getting the cardinal number of that, the number of elements. So we can see that there's a lot always happening with these questions. It's not always just the problem solving and finding what x is or finding or missing values. It's those little extra bits at the end as well that can catch us out. So we'll do one last question. So there's 100 students surveyed to find out whether they drank tea, coffee, or a soft drink. These are the results. 24 had not drunk any of the 3. That goes on the outside. 51 drank tea or coffee but not a soft drink. So 51 drank tea or coffee but not a soft drink. So 51 going in the center part there for us. Okay. 41 drank tea, so we can't really do much with that yet. 8 drank tea and a soft drink but not coffee. So tea and a soft drink but not coffee is here. 9 drank a soft drink and coffee. So 9 drank a soft drink and coffee. That would be that full aspect there in the center there for soft drink and coffee. Now we haven't worked out one aspect of that yet. So we haven't actually worked out whether who the people are that only kind of did part of that or who the people are who did all 3, but we're told it. So we don't even have to work it out. 4 people drank all 3. 9 drank a soft drink and coffee. We've already counted 4. So we're going to have 5 there. 20 drank at least 2 of the 3. Okay, 20 drank at least 2 of the 3. So let me see. I feel like I've put in something incorrectly. I have put in something incorrectly. Okay, and it's this 51 here. Okay, so here's a good one for us to point out. It's always good to learn from your mistakes. So let's have a look at it. So tea or coffee. And I've made a mistake there because I took it as tea and coffee. But obviously that's an awful lot of people. So tea or coffee means they are in T union C. So they're in one aspect of that. tea or coffee. Okay, they might have drank tea, they might have drank coffee, but they didn't drink a soft drink. Okay, so they drank tea or coffee. So that's nearly like a total. That's nearly like a total aspect that we're looking at there. Okay, so tea or coffee. Tea or coffee. Okay, so let's work out some of the other aspects that we have then. So I need to get rid of that one. I'm told that 20 drank at least two of the three. So from before, we know that's kind of this middle part here. So 20 people should be there. So 8 plus 4 plus 5, that's going to give me 17. So I have 3 that are unaccounted for there that I haven't added. Okay. So I have 3 that are unaccounted for. I can work out, hopefully, how many people drank the different sections. I know 41 drank tea. So if I take away the 3, the 4, and the 8 from that, I can work out how many drank tea only, which is 26. Okay, so I know 26 people drank tea only. I know then that 51 drank tea or coffee. So that could have been tea only, it could have been tea and coffee, or it could have been just coffee. So we're going to have 51 take away the 26 and take away the 3. Okay, so 51 take away 29 is 22. And lastly, I want to see how many people drank just a soft drink. How many people drank just a soft drink? And I can add up all the information I have so far. So 26 plus 3 plus 22 plus 8 plus 4 plus 5 plus the 24 on the outside. That gives me 92 people. I should have 100. So there's 8 people who drank a soft drink only. The probability somebody drank tea or coffee, well, we were told 51 people drank tea or coffee. So, or in fact, that was actually tea or coffee, but didn't drink a soft drink. Tea or coffee means union. Okay, tea or coffee means union. Means union. Okay, they may have drank a soft drink, we don't know. So we need to add up all those parts there. So 26 plus 3 plus 22 plus 8 plus 4 plus 5 gives you 68. So the probability is 68 out of the total 100. 68 out of the total 100, which breaks down to 17 over 25. The probability then that someone had drunk tea and coffee but not a soft drink, so tea and coffee but not a soft drink, is 3 out of 100. Okay. So there's a fair bit going on in all of those questions there and the examples that we did. The main things to watch out for, the main things that you need to look at, are the steps that we're following there, and even just paying attention to the fact that I've said let x be the unknown value. In a lot of the questions there, we got away without that. We didn't even need to really use that or utilize that. We were just working out from what they've told us. We maybe had one part missing that we were able to find. So it's just kind of looking at it logically, talking yourself through it, and then letting yourself work out kind of anything that's missing there. Okay, and even up to that point, if you can't work it all out, filling out as much as you can up to that point then.